Okay, this is our third video in Equilibrium Part 3 PowerPoint presentation. Oh, sorry, that was from our last video, which was starting with reactant only. So I'm going to work through an example where we're starting with only product amounts. So the same reaction, a similar problem, and you'll see pretty quickly what's different. So if you're still uncomfortable with rice tables, I would go back to the first one. This one I'm going to work a little bit more quickly. Okay, so I have a reaction. I have a K value of 2, and I have a balanced reaction. And in the problem, I'm asked what are the equilibrium concentrations? I'm given an initial concentration of my product, an initial. So I like to make sort of a box, my I line for initial, C for change, E for equilibrium. This is why they're called ICE tables. And then our first line is a reaction, so some people like to call it a rice table. Okay, I'm told initial concentration of NO2 is 0.38 molar. I'm not specifically given an amount of N2O4. So that one is 0. Now here's what's different in the last problem. Whatever you're given an initial amount of, if you are not given any on the other side, your negative on your change line, your negative has to be under the side that you were given some initial amount. So this will be negative, bring down the coefficient 2x. This one, I didn't start with any, so that means I'm gaining. This is shifting back, right? We have two arrows. If I have all product to reach equilibrium, that means I have to take apart, disassemble this atomic Lego set to build this reactant. So I'm gaining plus, coefficient is an understood one, x. The signs always have to be different, have to be opposite when you cross that equilibrium arrow, or arrows. Okay, and then this step isn't so bad. Once you get those two, you're just combining, adding together those first two. So 0 plus 1x, I'm just going to write x. 0.38 minus 2x, I don't have a way to simplify that. All right, so that's my first step that I do, is I like to set up the rice table. My second step is to set up the K expression. So I have 2 is my value for K equal to my product, 0.38 minus 2x entire quantity squared divided by x. Okay. All right. So now I need to solve for x. Oh man. All right. 2, multiply both sides by x. 2x equals, now I have to do what we call FOIL. Now you're like, oh, that's why college algebra is a prereq for this course, or higher, college algebra or higher. All right, so this is first FOIL, 0.38 squared outside, negative 2x times 0.38 inside, another negative 2x times 0.38, and then last, negative 2x times negative 2x is plus 4x squared. And that's all equal to 2x. And I want this to be equal to 0. So once I multiply these out, I will subtract the 2x to move it to the other side. Okay, so I've got 0.38 squared minus, let's do 2 times 0.38, that should be 0.76. 0.76 minus 0.76x minus 0.76x, because I have two of them. 1 minus 1.52x when I combine like terms, and then still plus 4x squared. I'm going to subtract that 2x from both sides to make it equal to 0 on one side. Okay, so now I have 0 equals 0.38 squared. Negative 2x minus 1.52x is negative 3.52x plus 4x squared. Now I can use the quadratic. This is something you need to be comfortable doing even if you have your calculator set up to solve it for you. A equals 4, B equals negative 3.52, and C equals 0.38 squared. I just didn't bother plugging that in, but you are more than welcome to. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So now I'm going to set that up by plugging in the A, B, and C values that I got. X equals the opposite of B, which is positive 3.52 plus or minus the square root of negative 3.52 entire quantity squared minus 4 times A, which is 4, times C, which is 0.38 squared. I just didn't multiply it out. Divided by 2 times 4. Okay, so let's see. Let's multiply some of this out. Okay, so let's do 3.52 squared. Let's get that number going. I got 12.34. And then let's do 4 times 4, which is 16, times 0.38 squared. 0.38 squared times 16. All right, 12.3904 minus 2.3104. So under that square root, if I haven't made an error, I have 10.08. So I have 3.52 plus or minus the square root of 10, roughly, divided by 8. Okay, let's see. So the square root of 10.8 is 3.175. Okay, so let's try 3.52 minus 3.175 and divide that by 8. I get a value of, so I'm going to call it x1 from my subtraction, 0.043. And what if I add it? I'm going to have 3.52. Here, let me put my screen on this side. Here we go. 3.52 plus, I think this is going to be way too big, which is why I did the other one first. 175 equals divided by 8. 0.83, I'm going to round to 7. So x2, I get 0.837. So how do we know which one to use? One is going to make sense and one isn't. So let's go back to our ICE table. We're asked for the equilibrium concentration. So if I'm starting with 0.38, can I subtract 0.8 from that? No. 0.38 is less than 0.8, so that cannot be. The x2 value, 0.837, doesn't make sense. If you plug your value for x back into your equilibrium line values and you get a negative number, dead giveaway, That is not okay. All right, so that means our equilibrium concentration of N2O4 is just X, so it's just equal to 0.043 molar. My equilibrium concentration of the NO2 will take just a second. That's what I have to solve for. That's 0.38 minus 2. And remember, I solved for X. I didn't solve necessarily for any individual concentration. If X is the equilibrium concentration, that means that on the equilibrium line, it's represented by only the value X. Everything else I'll have to do a little mathematical trickery. Okay, so 0.38 minus 2 times 0.043. Okay, and I get 0 point for my equilibrium concentration of NO2, I get 0.294. And we're talking about concentration, so this is molar. Okay, so remember we can check our answers. We can check our answers, our math answers, we can check mathematically by setting up the K expression, plugging in the values that we just solved for, and determining, hey, do I get that value for K back? So I set up the K expression, I plug the values that I just solved for back into the equation, and then I want to evaluate, do I get very close to 2? All right, so I'm going to square 0.294, and then I'm going to divide by 0.043, and I get 2.0101 and some more digits. It's not exact, but I did have to round, so I'm really comfortable with that. So this tells me that I did the math correctly. So I would recommend checking your answers every time. Why not?